All right, here's our bell work for today's lesson. Determine if the square root of 72 is rational or irrational. Well, the first thing I see here is that it is the square root of a non-perfect square. Now, the next closest square root, it looks like it would be 81, maybe you could say 64, but this is 72, which is definitely not a perfect square. That's this option right here. Well, does that mean it's rational or irrational? That's irrational. If you ever take the square root of a non-perfect square, you automatically end up with something that's irrational. All right, there's our objective for the day. I can solve equations where the variable is squared. Take 15 seconds and copy that down, please. All right, square roots in equations. So a square root asks what the side length of a square is from the area, right? Another way to look at that, which we've seen more often, is what number multiplied by itself, or it's asking what number multiplied by itself would give you that value. All right, which we've seen this example before. If you took the square root of 100, is really asking what number multiplied by itself is 100, right? And we know that the answer to that is 10. That's a perfect square for us. Makes that very simple. However, this is what we call the primary root, okay, or the principal root. It doesn't really matter about that, but it's just this value right here, because in actuality, what number multiplied by itself is 100. 10 is only one of two values that you could multiply by itself to get 100. The other value is negative 10. Okay, so what we end up with is, in actuality, two values that will work here. And so when we see equations, we're going to want both of those values. In Canvas, when you enter your answers, you actually have to use a comma between these. You'll see that it separates it into two separate boxes, and then that's how we're going to enter our answers, okay? Now, going back, if you have the square root of a number and you just saw that it said evaluate, we just want the positive value, but now with the equations, we're going to want two values because there's two values that will make the equation true. So we may have to use some principles of equality to get there, though, all right? So if for some reason we have like a square root like this, and maybe something's being added or subtracted to it, and then it equals something, we may have to use the subtraction principle of equality to zero that value out, and so that will isolate the square root, okay? So generally speaking, we use the addition or subtraction principles of equality to make zeros, which we've seen quite a bit of, but in some cases we've seen also that you can use multiplication or division to make ones. Now in the past, when we were solving equations, we were focusing on making the coefficients one, but now we may see this otherwise. Now, along with these principles of equality, there are principles of equality for radicals as well. It's just we have to be careful with the radicals just because of their nonlinear nature. And you don't have to worry about nonlinear nature means, but here's what I'm talking about, okay? If you have this, and so pretty much ignore this first part right here. If you took the square root of x and squared it, you're just going to get x, okay? But the same is true down here. If you take the square root of x squared, then you get x as well. What happens here is that the square root and the square, they pretty much make each other a phantom one. Same down here, this square root and this square pretty much make each other go away, so you're just left with x in both cases, okay? Well, why is this important? Is because if you needed to, like if you had a to the power of n, it probably wouldn't look like that, right? Maybe you'd have, let's show a to the power of n equals something else, like j, okay? Well, what you can do is you can take the square root of both sides, and that's okay. That's what I'm talking about when I'm talking about a principle of equality. That is with roots. Or instead of taking the square root, you could even take both those values if you wanted to for some reason. And again, just whatever you do to one side, you got to do the other side. And that would include with powers as well. So if you wanted to raise that to the power of 2, you could do that as long as it's to both sides. Or maybe for some reason you want to take the cubed. You want to cube both sides, and that's fine too. Okay, again, principles of equality, really, they just kind of boil down, even with these different principles with roots and exponents, it's just whatever you do to one side of the equal sign, you must do to the other side, okay? And again, that includes for roots and exponents too. So let's go ahead and solve this one. Now remember, in order for this to be solved, what we really need here is for the final solution to just be x. X equals something, not x squared, right? So just like we saw in that last slide right there, we're gonna have to take the root. A root will undo an exponent like that. So I'm gonna take the square root of this, and it's just a square root. If it was a cube root, then I would need some indexes here, okay? But if I do this to one side, I must do it to the other side as well. Now you should look to simplify this, just like it says here, we want this answer in simplest radical form, but the square root of 37, 37 is prime, so it can't be simplified any further, which means this is kind of our answer. Okay, remember what we saw two or three slides ago, there should be two answers here, okay? And really the exponent tells us that we're expecting to see two answers, and this is only one of them. Now, the other answer is very much related to this one. It's similar to it, it's just that, remember we need a comma to separate these, but it's the negative value there. So you got positive square root of 37 and the negative square root of 37. Can we even check this? Well, yeah, we can. Let's take x squared equals 37, right? That's what this needs to be true. Okay, so I can put a question mark over there. But instead of showing an x right here, let's start with that first value, the square root of 37, okay? So square root of 37, let's put this over here, but it's squared, and you can use parentheses there if you'd like. But what happens with this, square root of 37 squared is just 37. Well, that means that it would equal 37 right there, which means that right here we're looking at a true statement, okay? So since it's true, this square root of 37 would make it true as well. But what happens if we make it negative? Well, it's negative square root of 37 times also a negative square root of 37. This will produce a positive 37 as well, which means that that also is true. And so we see that both answers that we've shown will, in fact, make the original equation a true statement. Therefore, these two are our solutions, which is what we want. Okay, so how about something like this? So that last one couldn't be simplified. This one is going to be simplifiable though, okay? So I got c squared equals 144. I can take the square root of both of these. It's just that since I'm solving an equation now, I will get c equals, that's good. But I'm expecting two answers here, okay? So the square root of 144, it's the square root of a perfect square, that's just 12. But remember, we're looking with c squared, so we're expecting the two answers, not just 12, but also negative 12, okay? And so you just type this in on Canvas, it'll be a box. You say 12, put a comma in there, and then we'll give you another entry there. You just type in negative 12, and it doesn't matter if you put the negative first. Okay, but again, let's just check to make sure this would work. So in the original equation, c squared equals 144. That's what it needs to equal, right? So if I take the c, and instead of putting a c there, maybe I put 12, right? Well, 12 squared is 144, and well, last time I checked, at least for now, 144 does equal 144, that's true. Okay, so that shows that at least the 12 will make the original equation a true statement. Let's try and make this negative 12. So again, that's a negative 12 times negative 12. Still makes a positive 144, which is still true. So that tells us that both of these are solutions to the equation. Now, in the past, we've seen equations that have only one answer. We've seen equations that have no answers, meaning you could never make it true, and also equations that have infinite solutions. This one, we're now seeing equations that have two solutions. And it is possible to have 3 and 4 and so forth, but for now we're just focusing on these two. Okay, so here we want this in simplest radical form, and the t squared's on the other side, no problem. I'm still going to take the square root of both of these. Okay, so that the square root and the power of 2 there are going to undo each other, but the 24, I know I can simplify that. Okay, so on this one, I will use prime factorization if I see other ones that I may not. Prime factorization, okay, because this is what we use with cube roots, and so it may be kind of fresh in the mind. So 24 I would split up, I'd probably say 6 and 4. And then 6 would be 3 and 2, both of which are prime, and then 4 splits up into 2 and 2, right? So I would look at the square root of 24 instead as, I'm going to rearrange those 2 times 2 times 3, and then split those up, right? We're looking for pairs, so that's 2 times 2 square root times the square root of 2 times 3. And yeah, these are being multiplied, need a little bit more space. But I get 2 out of that perfect square, and then I also have the square root of 2 times 3, which is 6. Okay, well, going back to what we have up there at the top there, t equals that stuff, t equals 2 times the square root of 6. But remember, with this exponent, we are expecting 2 answers. So the other answer is pretty much going to be exactly the same. It's just we got a negative out there in the front. So 2 answers right here. Now you could plug this back into the t right there and check, but I'll skip the torture. These two work. Okay, so here we have an equation, right? And the last thing we want here is for anything being multiplied by my x squared or anything being added or subtracted to my x squared. So I'm going to start zeroing that kind of stuff out, okay? So I'm going to go straight into principles of equality on this one, meaning I don't want that minus 7 with my x squared. So I'm going to add 7 to both sides. So I got negative 15 plus 7, which is negative 8. And it's going to equal my negative 2x squared. Just drop that. And yeah, negative 7 plus 7 does zero out. Okay, so I got negative 8 equals negative 2x squared, but I also don't want that coefficient of negative 2. So I'm going to have to use another principle of equality to divide both sides here by negative 2, making that a phantom 1 x squared. And then we got negative 8 divided by negative 2, which is 4. And now that I got the x squared isolated all by itself as a coefficient of a phantom 1, nothing added or subtracted to it, I'm now ready to square root both sides. So this will give me an x value, which equals the square root of 4. That's perfect square for 2, but also negative 2. Right? Negative 2 times negative 2 is 4. That checks off. Both of these check off. And we now have the 2 solutions for our original equation. Let's go back and check, right? So I'm not going to show much work here, but right, if I replace the x with 2, I got 2 squared, which is 4 times negative 2. That's negative 8. Or that's what we saw right there. Minus 7, that's negative 15. That checks off. But if you make this x a negative 2, that's negative 2 times negative 2, which is 4 times another negative 2 is negative 8 again, and negative 8 minus 7 is negative 15. It checks off for both values that we found. Okay, now about this one, well, same process. We just want to isolate that c squared. Okay, so I'm going to use the principle of equality to do that. I don't see any distribution or combining like terms necessary. So that means I can zero out that negative 8 right now by adding 8 to both sides here. So negative 8 plus 8 zeros that out. I can drop my negative 9c squared. And yeah, that'll equal negative 26 plus 8, which is negative 18. Yeah, there we go. And last of all here, I want to make that coefficient of c squared a phantom 1 like we see here. And to do that, I will divide both sides by negative 9. So I'm showing the division a little bit different than last time. Negative 18 divided by negative 9 is 2. And now I am ready to square root both sides to make this c equals the square root of 2. But again, we're expecting 2 answers here. So not just the square root of 2, but also the negative square root of 2. And again, you can go back and plug that in. Check. Both work. Both are solutions. Now this one we got away with. We didn't need to do any simplification here, right? It's just square root of 2. That can't be simplified. But we know that we can use the calculator for that as well. All right, here's another one. Let's go and do this one. So principles of equality, right? Let's bring this down. Principle of equality, boom. I don't want that minus 8 with my negative 9m squared, so I will add 8 to both sides. Okay, so that will zero that out, but I can then drop my negative 9m squared, further isolating the m squared, but or at least getting closer. So this will equal negative 80 plus 8, which is going to be negative 72. Okay, last thing here, right? We just want the m squared to have a phantom 1 coefficient, so the negative 9 coefficient will become a 1 by dividing it by negative 9. It's just if I do it to one side, I got to do it to both sides. So negative 72 divided by negative 9 is 8. It's positive 8. Okay, so just as a quick reminder, we can put this into the calculator as I take the square root of both sides to get m, or whatever m is, because the square root of 8 can be simplified. So how do we put this into the calculator? Well, we need to access the square root symbol in the calculator. So to do that, we got to push the second button in the top left corner of the calculator. Then I push the x squared button, which is one button to the left of 7, then type 8, right? Then you see on the calculator, it actually says the square root of 8. Just push enter, and you'll see it will give you 2 times the square root of 2. So that would be the simplified form of the square root of 8, 2 times the square root of 2. Just don't forget your second answer there. It's also 2 times the square root of 2, but this one's negative. Boom, there it is. And again, this is the process. Second x squared will give you the square root symbol on the calculator. You can type anything in there. It will simplify everything. All right, so that ends our lesson right here. I can solve equations where the variable is squared. So you guys go ahead and grab a computer now. Get this done so you don't have to take anything home. And you can spend more time with your family. Okay, this is 9.4 on Canvas. Go in, get it done. We'll see you guys later.